Let's talk about scientific measurement. Scientists make measurements. Now, here's the key idea. Physicists in particular use math and really good measurement to make astonishing discoveries about the universe. In fact, good measurement, as it says in your textbooks, good measurement is a hallmark of science. The more precisely and accurately you make measurements, the better your discoveries, the more accurate and precise your discoveries will be. For example, you may have asked yourself the question, how far away is the sun? This is something that people have wondered about for thousands of years, actually. Now, how might you measure the distance between the sun, represented on the left, and the earth, represented on the right? It's too small to see. Well, that's a really big distance. Let's use a tape measure. No, that's not going to work. Or you might think of sending a rocket from the earth to the sun, which would end in disaster. How would you measure that distance from the earth to the sun? It turns out that thousands of years ago, somebody already did. In fact, there was a Greek named Aristarchus who measured the distance from the earth to the sun without even leaving the earth. Have you ever noticed when you see the sun and the moon in the sky at the same time? Aristarchus did, and in fact he waited until a day when not only did he see the sun and the moon in the sky at the same time, he saw the moon when it was half full, like it is in this drawing here. And it turns out that when the sun, or rather when the moon is in the sky and it is half full, the distance, or rather the direction of your line of sight, represented right here, and the line of sight from the sun to the moon, those two lines of sight are at right angles. That's why you see only half of the moon, because the line of sight from the earth to the moon and the line of sight from the sun to the moon are at right angles. So Aristarchus waited for a day like that, and then he said, aha, if I just know the angle x right here, if I just know x, I will be able to calculate, using math, the distance from the earth to the sun. Now, it turns out he already knew the distance from the Earth to the moon, which is 385,000 kilometers, and he needed that bit of information as well in order to do the mathematical calculation. So all he had to do then was to measure x very, very carefully. So he did. And he found out that x is 87 degrees. And he calculated then the distance from the Earth to the moon, and he found out that it is 20 times 385,000 kilometers, or 20 times the distance to the moon. Pretty good, right? Well, it turns out he made a small mistake. The distance, or rather the angle, is not 87 degrees, it's actually 89.8 degrees. 3 degrees difference. You might think, meh, not a big deal. He was only off by 3 degrees. Well, it turns out that that small lack of precision and accuracy in his calculation, or rather his measurement, leads to a difference of 400, right? The actual distance is 400 times 385,000 kilometers, 400 times the distance from the Earth to the moon. Just a small difference of only 3 degrees led to such a huge mistake. Good measurements are a hallmark of good science. Now, if Aristarchus had had better instruments, maybe he would have made a better measurement. But you can see how important good measurement is. 20 is very different from 400. So, it ends up that the sun is about 150 million kilometers away. Now, you might wonder, what's its diameter? I'm going to leave it up to you, if you don't know the word diameter, to look it up. And it turns out that you can measure the diameter of the sun without even leaving the Earth, simply by making a very careful measurement of the diameter of a penny.